Hi all, welcome to the color image processing video session 1 of digital image processing module 4. The content are color image processing, preview, color fundamentals, pseudo color image processing and MCQ. For a long time, I limited myself to one color as a form of a discipline, Pablo Picasso. It is only after years of preparation that the young artist should touch color, not color used descriptively that is, but as a means of personal expression, said by Henry Matisse. So, why use color in image processing? Color is a powerful descriptor. Object identification and extraction. Example, face detection using skin colors. Human can discern thousands of color shades and intensities. So, color image processing is motivated by two factors. So color is a principal descriptor that often simplifies object identification. Human can discern thousands of color shades and intensities. So color image processing is divided into two categories: full color image processing and pseudo color image processing. Full color image processing images are acquired with full color sensors, colors scanner. Images are acquired from full color sensor or color scanner or equipments. Pseudo color processing. In the past decade, color sensors and processing hardware are not available. Colors are assigned to a range of monochrome intensities. Color fundamentals. In 1966, Sir Isaac Newton discovered that when beam of light passes through the glass prism, then the emerging beam of light is not white but consists continuous spectrum of colors, that is Vibgayar. Basically, some colors that humans and some animals perceive are determined by the nature of light reflected from the object. You can see in the diagram in the figure color spectrum seen by passing white light through a prism, that is Vibgayar. You can see that violet, indigo, blue, green, yellow, orange and red color. It's called as Vibgayar. Visible light. That is chromatic light span the electromagnetic spectrum from 400 to 700 nanometer. That is the electromagnetic range of chromatic light. So you can see from the diagram wavelengths comprising the visible range of electromagnetic spectrum. It is from 400 to 700 nanometer is the visible spectrum band. Color fundamentals continued. The color that human perceive in an object, that is the light reflected from the object. You can see here the source and the white light, and the light reflected is green light, that is perceived by an eye. It is perceived from an object, that is green light. So physical quantities to describe a chromatic light source. Radiance total amount of energy that flow from the light source measured in watts. Luminance, amount of energy an observer perceives from a light source measured in lumens, LM. For infrared light, I radiance but zero luminance. What is brightness? Brightness is a subjective descriptor that is hard to measure, similar to the achromatic notion of intensity. How human eyes can sense light? 6 to 7 million cones are the sensors in the eye. Three principal sensing categories in eyes: red light, 65% of cones; green light, 33% of the cones can recognize green light, and blue only 2%. You can see from the graph here. Here you can see the range of recognition, that is blue is recognized by 445 nanometer and green is 535 nanometer and red is 452, that 700 nanometer, that is 575 nanometer highest, 535 nanometer highest peak, 445 blue. Primary and secondary colors. In 1931, CIE, that is International Commission on Illumination, defines specific wavelength values to the primary colors. For blue color, they will assign 435.8 nanometer. For green color, the wavelength value is 546.1 nanometer. For red, 700 nanometer. The secondary colors are mixtures of these primary colors. That is green plus blue is equal to green plus blue. You will get cyan. Red plus green, you get yellow. Red plus blue, you get magnet. Mixtures of all these colors, you will get white. So application of additive nature of light colors, that is color TV. Red, green, blue color monitor. So you will get color picture. Pseudo color image processing. Pseudo color image processing means assigning colors to gray values based on a specified criteria. For human visualization and interpretation of grayscale event, used as highlighters in order to attract attention. There are two methods. One is intensity slicing, another one is intensity or gray level to color transformation. We'll go for multiple choice question now. Why use color in image processing? Color is a powerful descriptor, object identification and extraction, both A and B, none of the above. So what is the answer? Both A and B. Humans can discern dash of color shades and intensities. Options are thousands, 10,000s, both A and B, none of the above. So what is the answer? The answer is thousands. Category of color image processing in number 1, 3, 4, 2. The answer is 2. Chromatic light span the electromagnetic spectrum from 400 to 700 nanometer. It's true or false? It is true. The color that human perceive in an object, the light reflected from the object, the light refracted from the object, are only A or both A and B. The answer is the light reflected from the object. Luminance measured in terms of lumens. Lumens meter, both lumens LM or lumens M, both A and B, none of the above. The answer is lumens LM. Three principal sensing categories in eyes. Red light 65% cones, green light 33%, blue light 2%, all of the above. Answer is all the above. The wavelength values to the primary colors defined by CIE, International Commission in 1931. B is equal to 435.8 nanometer, G is 546.1 nanometer, R is 600 nanometer. B is 435.8 nanometer, G is 546.1 nanometer, R is 700 nanometer. C only B, D none of the above. So the answer is what? B. B is B. Blue is 435.8 nanometer, green 546.1 nanometer, red is 700 nanometer. Secondary colors are green plus blue is equal to cyan, red plus green is equal to yellow, red plus blue is equal to magenta. This is true or false. A is true, B is false. Answer is true. For pseudo color image processing, the relevant two methods are intensity slicing, intensity or gray level to color transformation. C is both A and B, none of the above. The answer is C, both A and B. Thank you. We will stop the session here.